Welcome to this 3D MedNet interview with Mike McAlpine, Benjamin Mayhew Associate Professor of Mechanical Engineering at the University of Minnesota, USA. Today we will be discussing his work on 3D printing functional materials and devices in the medical field. Hi Mike.
Hi Lauren.
How are you today?
I'm great, how are you?
Great, thanks, and thank you for joining us. So your background is in chemistry and you're now in a mechanical engineering department. How did you become involved in 3D printing in a medical context?
Yeah, it's a good question because, when you think of chemistry and mechanical engineering, they sound like two completely different things. But really what it means is that we can use my knowledge of chemistry, which kind of provides me a deep insight into how materials work, how materials respond in different ways to external stimuli and whatnot. And then in the mechanical engineering department, we have talented students who know how to build instruments. For example, these kind of advanced manufacturing capabilities like the 3D printers that we have, which are custom built. So these are not commercial off-the-shelf 3D printers. We custom build them to handle a range of different materials beyond the hard plastics that are normally printed in a commercial 3D printer. And so, that means that with our printer, we can process functional materials like electronic materials, biological materials, other types of materials in unique ways, and process these functional materials into compelling devices, whether it's next-generation electronic, biomedical devices. And so, it really, having this versatile platform and students who are also come from a variety of different backgrounds, electrical engineering, chemical engineering, mechanical engineering, chemistry, that allows us to really tackle a broad range of problems using this custom-built 3D printer that we have, which is a very versatile tool.
So please could you tell us a little about your group's current research focus?
Yeah, so the focus of our group is 3D printed functional materials and devices. And the interesting thing about that is that allows us to have a focus, which is building these custom-built 3D printers that can handle a diverse range of materials. But then the versatility of that tool that we build, and which is a unique tool because it can't be easily purchased since we do all the custom building ourselves. The versatility of that tool allows us to tackle a broad range of problems. So the problems that we tackle can be in the biomedical space or the electronic space or something completely different. There's really a broad range of problems that we can tackle. So it's really nice because we have this core focus, which is this 3D printed functional materials and devices, and yet still we don't get constrained or bored by doing that one thing because it can be applied to so many different areas due to the versatility of the tool and the variety of different materials that it can handle.
That's great. So in a recent paper, 3D printed bionic nano devices, you discussed the use of 3D printing to interweave biological and functional materials in order to create bionic devices. Could you outline this process of interweaving and what printing mediums are used?
Yeah, so this is a big challenge in general material science, and a few years ago we kind of had that was my first exposure to 3D printing. In 2011 I saw a talk by Hod Lipson, he's now at Columbia, and at the time he was at Cornell, and he gave a talk about these tools called 3D printers. I'd never heard of them before. That was only 5 years ago, actually. And basically what he showed during his talk is that these tools can make these intricate hard plastic objects, but also he had hijacked one of these tools to put into the tool flour, and he was printing food. And one of the funny things that he did was he printed a muffin where if you slice the muffin in half, there's actually a letter written on the inside of the muffin in food coloring. So it was like I call it like an espionage or spy muffin. So I saw this talk, and I was sitting there, and I was just amazed at what this tool could do. Again, I think probably everyone now has at least heard of 3D printers, although still, not that many people own them because, we can get back to that later, but it's not clear what the killer application is. But but when I saw this talk, I thought to myself, I bet you could, instead of hijacking these things and putting flour into it, I bet you could put all kinds of interesting things and materials into these machines, such as functional electronic materials, biological materials, and those sorts of things. And I sat down with my student when I got back. I was so excited, and I thought, we have to come up with an idea here where maybe we use the same tool to print biologicals like cells and then electronics in the same tool, and then use this three-dimensional aspect of the 3D printer to interweave, as we call it, the biological and the electronic in 3 dimensions. And that's kind of where we came up with this idea of this bionic ear, which is really our kickstart into the 3D printing world.
So you mentioned the ear, and what other kinds of products and devices can be created using the interweaving technique?
Yeah, so the first demonstration that we did, this bionic ear, so again, this was 4 or 5 years ago. So what we did is we went out and we bought a $2,000 3D printer called a Fab at Home. And I'm not even sure if that company is still in business, but it was a cheap tool, $2,000. And the nice thing about that is instead of buying one of these expensive machines that can do really complicated structures, handle plastics, and print them at fine resolution, we bought a cheaper machine. And the reason for that is because those expensive machines, the expensive 3D printers, can only handle proprietary polymers that the company specifically designs for that printer to print. And if you put stuff into the printer like we wanted to do, we wanted to put all kinds of weird stuff like cells and nanoparticles and electronics. If you try to put those in those expensive commercial printers, then pretty quickly the printer will jam, and the nozzle will jam, and the company's not going to fix it for you because you put stuff in there that you weren't supposed to. So it worked out well for us because we didn't have to spend a lot of money. We only spent $2,000 to buy a cheaper tool. Now, it was kind of a pretty crude 3D printer. I mean, it was just one head instead of multiple heads. There was only one, and the resolution of that was pretty poor. It was kind of a slow, clunky printer, but it got the job done because it allowed us to play with it and customize it and put things like cells into it, put some electronic materials into it, and print out this structure that we call bionic ear, which is basically a cartilage-based organ that we printed where you have an electronic coil that's interwoven throughout the ear, which actually gives the ear the ability to listen to music.
Oh, wow. So earlier this year, your team published a paper on the recent creation of a 3D printed nerve regeneration pathway. Could you tell us a little bit about this, please?
Yeah, so after we did that ear project, we thought, this probably has legs. There's probably a lot more we can do with these printers. And so that's when we set out to build some custom printers. And right now, if that ear printer, we call that our first generation. Right now we're on our 3rd generation printer. So now we have multiple heads. We can do fine resolutions, lots of different materials integrated together. And so that allowed us to do more complicated projects. And one of the exciting projects, one of the more recent ones that we published, was this 3D printing for nerve regeneration. And that came about because we were talking to someone who said, maybe you should look at the peripheral nervous system and whether you can regenerate nerves and maybe use 3D printing for that. And we sat down and we came up with this unique idea that we hadn't seen before, which is maybe the 3D printer can give you the ability to custom build scaffolds that are personalized to the patient. So if they have complex nerve injury, meaning instead of just a single nerve being injured, let's say you have a branch structure or some sort of complicated branch nerve system, if if that gets damaged or destroyed, then maybe you can custom build, using the printer, a scaffold to regenerate those nerves, which is in the exact geometry as the nerve structure that was damaged or destroyed. And that was enabled by using a combination of a 3D scanner and a 3D printer.
So you've mentioned some, but what are the benefits of using 3D printing to create devices such as these?
Yeah, well, the advantage is the customization. So, the thing about 3D printing is it's not necessarily a tool that one would use to mass manufacture similar objects, because it is a serial process. It writes things, line by line, layer by layer. So it's slower than, let's say, a molding technique or some other type of rapid manufacturing technique. It's a serial process. But the advantage is that you can custom build devices right on the spot that are customized to the patient.
Yeah.
And so in this particular case, we had a nerve structure which was branching, which, as far as we knew, had not been in the literature. No one has regenerated a branch nerve structure. And so the reason why we were able to do that is because we took something called a 3D scanner, which goes in and scans the complicated nerve branch, and then we take that scanned information and geometry and fed it into the printer, so the printer could print a scaffold that also branched, and it branched in the exact way as the original nerve branched. So the advantage of the 3D printer is you get this on-the-spot customization or personalization to the patient that you would never get if you just had sort of a off-the-shelf, one-size-fits-all mass-manufactured device.
So now, more generally, what factors, if any, do you think could limit 3D printing from being used more commonly in the medical field?
Well, so the thing about the 3D printers is, in order for it to really be used on a regular basis, you need to have a printer that can reliably, on the spot, print functional materials. And again, most of the printers that you see now are limited to these hard plastics, and those have very limited utility. I mean, there are some cases where having some sort of hard plastic implant is suitable for a fairly simple or crude application, but I think going forward, what we really like to have are implants that can respond to their environment, or they're functional. Maybe they have electronics built into them. Maybe they can stimulate the regeneration process, or maybe they can flex and bend and fold over time dynamically. And in order to do that, you have to go back to the printer itself, and you have to ask the question, how do we build a printer that can handle these diverse range of materials, whether it's electronic materials, soft, ultra-soft materials, not just hard plastics, but soft polymers, and maybe even biological materials, if you want to introduce cells or whatnot that may help the healing process. These things are difficult to do. Even individually, they're difficult to do, but to have a single printer that can do all of them at once in a way that's as reliable as the commercial printers, the hard plastic printing, I mean, that's pretty reliable. You just give it the shape you want to print, it prints out the hard plastic, and you're good to go. But these other materials, they're more finicky, and they're more delicate, and especially trying to get them all into a single platform is really not that easy. So there's a lot of work that needs to be done on the printer development side of things, informed by material science, in order to really have one of these advanced 3D printers that can do next generation implants and dynamic implants and that sort of thing.
So finally, and looking ahead, your lab has worked on a range of medical and bionic 3D printed products, including biomedical, lab-on-a-chip and electronic devices. Which area of medical 3D printing do you think will see the biggest growth in the next 5 to 10 years?
Well, the exciting thing about it is that the 3D printing, I think, can impact so many different areas of medical printing. There's just so many. Now, I think in the short term, I think the thing that's really becoming most useful in the short term is using 3D printing for printing these organ models. And what these are models of organs where the way doctors and surgeons do their surgery now is they get MRI scans or CAT scans of an organ, and they get several slices of it, and then in their head they have to kind of visualize before they do the surgery, how these two-dimensional slices all fit together and what the three-dimensional structure will look like when they actually open the body cavity, and kind of do this kind of complicated mind game where they're trying to figure out how to do the surgery in their head from really what are slices rather than the full three-dimensional structure. So one nice thing that 3D printing is giving us right now is the ability to print a model of an organ that geometrically is exactly like the structure that exists in the body. You take a scan of what's going on in the body, you print something out on the spot that looks exactly like that, and so now the surgeon can practice the surgery on that model. So now he has a three-dimensional structure in front of him, a real object, not just two-dimensional sliced images, but a real object in front of him which matches exactly what he's going to be doing the surgery on, and he can practice on that before doing the surgery itself. And so that right now, I think, in the biomedical space, probably right now that's the most compelling use of 3D printing. But, going forward, what we can do are things that are a lot more complicated than that, because you can start to introduce electronics into these biomedical devices in a way that's unintrusive to the body. So you can do all kinds of things like promote regeneration, promote wound healing, have implants that respond to their environment, sort of like Terminator 2 type of healing in the body. And so going forward, I think sky's the limit. I think what we can do is take, everything that's being developed in the computational space with our laptops, cell phones, iWatches, and bring them into the biomedical space and get, high performance computing in the body to promote regeneration. But maybe even in the future, like we showed with our bionic ear, maybe you can even also use these implanted electronics to maybe even augment the human capabilities as well, and give people kind of superhuman capabilities that they didn't have before using this 3D printing approach.
That's so interesting to hear, and thank you very much for joining us today, Mike.